Light or curious, yeah. Yeah. The slider. Okay, guys, real quick, let's go next one here. Wyatt, did not know you perform such things here. Wyatt is shocked. Okay, so White is shot as a human cannonball, initial velocity of 67 feet per hour, or miles per hour, at an angle of 60 degrees from the horizontal. Oh, interesting. So now we have this. It wasn't bearings, right? It was actually 60 degrees from the horizontal. Find the magnitudes of the horizontal and the vertical vectors. Now what I want to do is I want to find the components of it. Sheesh. Okay, so let's draw it out. Let's see. So I want to know how fast is he going sideways and how fast is he moving up. That's what I want to know. So I'll go like this. So I'm going to go. Theorem, yeah. So I know, I know the hypotenuse. Is that right? I know the magnitude of the hypotenuse now. And it says 60-degree angle from the horizontal. So everybody okay? This from the horizontal means this one right here, right? Whichever direction is going, left or right. Should always be over there, yeah. All right, so let's go with it. I want to know the horizontal vector and the vertical vector. So I want to know actually the components of it. Interesting. Okay, so let's get some. Let's do this here. Let's go back to the book real quick here. Let's get some definitions for those and see the notation for it. So if I want the horizontal vector, what I do is I do this. I have, oh, sorry, went too fast. This one right here. So notice it's V, and then it has a little x next to it as a subscript. And it says the magnitude of V multiplied by cosine of theta. Does that make sense there? Okay, so let's go back real quick. People that want. So let me go back. I think this is easier to understand. Those that want an equation, go for it. I'll let you guys write down. You can write down the magnitude. I want you guys just write down these two right here. So V of x equals the magnitude of V cosine theta. And then we'll go back to our previous problem here. And so magnitude of y, which is going to be our vertical, right? Our vertical component. It's going to be perfect. Yep. The magnitude times sine of theta. Let's see if this writes. Okay, but let's go back to understand it here as opposed to just have an equation. Okay, let's go over here. Let's go over here. If I were to draw let's go with the explanation here. So if I were to put down a triangle right here, is that right? So you guys talk to me. How do I get this side right over here? I'll call it x. I know hypotenuse. I know adjacent side, which is hypotenuse of adjacent side. It's cosine, true. So isn't cosine of 60 degrees equal to adjacent over the hypotenuse of length? Is that right? If I do that though, I multiply both sides by 67 and it becomes x is equal to 67 cosine of 60 degrees, right? Which it would turn into vector form, right? And again, we're just putting extra pieces on here, right? But notice real quick, if I say, okay, I want the horizontal component, right? It's going to be like this. This is the horizontal component because it's the x. And notice this is just going to be the magnitude of this vector right here, right? That's just the magnitude right there. And then the angle is still the same. Angle is the theta that was given. So notice it's just this and this. Still same stuff. Could you have solved it without putting all the notation for vectors and all that stuff? Absolutely. And what'd you guys get? 33.5? Okay, I'm going to go with it here. I don't know, but I'm going to go with it. Okay, 33. Okay, are we good there? Is it 33.5? I don't have the answers on my sheet. That's why. That's why mine is off here. As long as we agree, or do we agree there? Okay, and then we got this one right here. We want the vertical vector. So what is this? The opposite side? Opposite hypotenuse. Which is that one? Tangent if you're going to use this, right? But if I wanted to go back to use my 67, what trig function connects opposite side and hypotenuse? Sine. Are we okay here? It'll be sine of 60 degrees is opposite, which kind of just labels y, over hypotenuse. Are we good there? Multiply both sides by 67. So 67 sine of 60 degrees. And notice all those components, the 67 and the 60 degrees, were in our problem to begin with. We good? So it's almost like you don't go back to the definition of the trig functions. You can just use the formula saying my vertical vector, or my vertical component, is whatever the magnitude of the hypotenuse multiplied by my angle of the horizontal. That will also give me, what do you guys get for the answer? 58. 58.8 or 58 point, is it 58.0? Okay. Oh, that's right. We've got to do what? Miles per hour. Is that right? Miles per hour. So that y is going up vertically. Is that right? A lot faster than he is horizontally. And then what happens is gravity takes over. Is that right? So that vertical component is going to go smaller, 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 smaller until it hits 0. And then it's going to start going down, down, down with a negative value to it. Okay. Megan, can you do the slider again, please?
Not it.
Okay, that's cool. Thank you so much, Megan. You can put it back. Okay, are we good with that? So the formula is given as well. We good? Oh, the answers? Yeah, 33.5 miles per hour and 58 miles per hour. Sorry, Eva, go ahead. Tell me. If we wanted to, we could plug in, if we could plug in 33.5 and 58 into a Pythagorean theorem, you should get 67 at the end again. Yes, you could have done that as well. Yeah, absolutely. Yeah, multiple ways once you find more. Okay, next one. Let's see. Next one is this one. Olivia, I did not know that. That's so cool. I guessed right. All right. Olivia shoots an arrow into the air, so its horizontal velocity is 30 feet per second, and its vertical velocity is 20 feet per second. Oh, it's the exact opposite. Now I actually know the components of it. I need to know the velocity of the arrow. Oh yeah, if you're giving it feet per second, you want to give it in feet per second. Yeah. So you guys talk to me here, this one, and if you got 36, you got it right. Absolutely. And then if you want to give me your, let's see, does it give the angle? No, find the velocity of the arrow. Perfect. Yeah. So let's see. We got this one. Let's see. It is horizontal component is 30 feet per second. The vertical correspondence is 20 feet per second. All right, there. So this little guy right here, again, some notation, but essentially it's just Pythagorean theorem. Is that right? So here's the way the book does it here, but essentially if you want to add 30 squared plus 20 squared and take a square root of it, you're going to get the same thing here. 100 plus 900. is 6, no, it's what, 12, 1300, is that right? That, okay, so it's almost, is that right? What is it? Is it like 35 point something? 35? 36.05. Okay, gotcha. Just slightly higher than that. Yeah, guys, talk to me here. Is magnitude and velocity the same? Because it says find the velocity of the arrow. What's up with that? Does velocity have direction? Right? Yeah. So velocity says you are going that fast, right? In this direction. So I got to give me direction. Yeah, it kind of depends here. So remember on last one on Wyatt's one, right? It said 60 degrees from the horizontal, right? Which was technically from the positive x-axis, right? So this one, when you shoot an arrow or shoot Wyatt with a cannonball, sorry, not shoot him, that's different. But if you shoot Wyatt from a human, as a human cannonball here, we usually don't give bearings of things, right? When ships are on the ocean, yes, those deserve some bearings, right? So this one, what I probably want to do is I want to do the same as I did for number 2, which is give me the angle of elevation or angle from the horizontal. Good. So let's go with this one here. So can you guys set up the triangle? Go for it. So that 20 that's on the vertical component, can I slide that 20 to the other side? Yeah, so I'm gonna in a sense add these two vectors together. Is that right? End to end. And do they form a exact 90-degree angle? Absolutely. Now they do. That's 20. That's 30. I also know the hypotenuse is 20. Sorry, 36 point something, right? But I don't want to use. And here's the thing: if I can get away just using my given values, I would like to do that. We're good. So 20 over 30, are we good there? So tangent is what I want, is opposite over adjacent. Can anybody give me that angle measurement? Okay, 33.66. Given value is probably the best, yeah. And now we had what, 36.05, is that right? So that was pretty close, right? If you're given like 36.4 and then you run it down to 36, now you're kind of having more error. But if you can use just the given values, that's the ones you want to use. Okay, good there. 33.7 is good. Let's write it out. Let's see what this means here. So the arrow is shot at 36 feet per second with an angle, you can say from the horizontal, or you can say with the angle of elevation of 33.7 degrees. Okay, all right, we're good there with that one. All right, if you wanted the correct notation for vectors, it would go like this. People that like equations here, you would write it like this here. And raise your hand if this makes sense to you right here. Tangent theta is the magnitude of the y component over the magnitude of the x component. Cool, all right. Okay, one more. One more. And tell me, are you guys okay with this one? Everything good? I got 3 people still writing it down, so go for it. Okay. All right, so this one is actually from your homework. This one I did I think it's the even problem off your homework. So then you guys have the odd question that's very similar to it. I got a couple of people still writing it out. Go for it. All right. All right, let's deal with forces now. Let's take a look at this one here. So, how about this situation? Oh boy. So Benny is a five years old and he weighs 50 pounds. Okay, he is sitting on a swing when his sister Stacy pulls him and the swing back horizontally through an angle of 30 degrees. So the angle on top is 30 degrees. Okay, and then stops. Here's what we need to do. I need to know the tension on the ropes of the swing and the magnitude of the force exerted by Stacy. Now the question is this: Stacy pulled him back, and right before she lets go, are all the forces neutralized? Right? Since it's, yeah, he's not moving, right? So all these forces somehow should make a triangle. Are we good? And so, did you guys do this physics? Concepts, okay. So notice. Okay, good. Okay, so let's see if this makes sense. So we have an angle here, right? Whatever that angle is. We need the tension of the rope, which is right here, right? We have the weight of this guy, which is right here. And then Stacy is pulling him back. So there's the horizontal force of Stacy pulling him back. So can I rearrange this so it forms a triangle somehow? Uh-huh. So yeah, that's. So we good. So let me see if we can do this correctly here. So tension on the rope, is that right? And now tension, interesting with forces, right? Because we're looking at vectors just now, right? Tension with forces are how much strain is on the rope, right? Which is technically the same thing as vectors in terms of force. Good. So let's get that t vector, that h vector, and that w vector kind of isolated. Are we good there? Since there's no movement, yeah, go ahead. Move them around. How should we move them around? Okay. Cool. Okay, I'm going to do it differently. Let's see if this makes sense here. I just need to form a triangle here. So I'm going to do is I'm going to move this guy. I'm going to move this guy over here to the front. Right here. So that little dot goes to here. I'm just trying to connect all the forces. So if I do that, this goes here. That's my T. We good? I scooted it over horizontally. My H is still in the same spot. Are we good? What should I do with the W force in order to form a triangle? I'm going to move it up. So this W force, I'm going to move this way up. And when I do that, I get this. And I have myself a right triangle. True, true. Um, it still should be positive because I'm just measuring the length of that. And the 30-degree angle, let's see, the 30-degree angle was right here, is that right? This was 30 degrees? So as long as this connects with something that's going straight down, it will still stay 30 degrees. So this little W force, when I slid it, when I was going to slide it up, does that still remain a 30-degree angle? Absolutely. So there's my 30-degree angle right there. And there's my little right triangles. True, true. What do I need to find? Find the tension on the rope and the magnitude of the force exerted by Stacy. So I need to know the tension here because that's a force. I need to know T and I need to know H. Can I just use regular trig functions now? Yeah, any connections, go for it. Give me any connections we need. Yeah, cool. So weight corresponds to force down. Let's see. Here's my angle. I'm going to go with the opposite side. Is that okay? With adjacent side. Trig function. Tangent. Tangent of 30 degrees would give me opposite over adjacent. Do I know what a, oh, hold on. Do I know what W is? That's right, it's 50 degrees. Okay, so even better yet. Yeah, because Benny was 50 pounds, is that right? So I need to know 50 tangent of 30 degrees. 29, okay. So there is a 29 pounds of pressure or of force exerted by Stacy. We good? Okay, how about the tension on the rope? That's right. Yeah. So now we're going to go, well, let's see. What we're given. What we're given is this one right here, right? Sine is adjacent. Oh, sorry, this one. And I need tangent. So let's see. Sorry, guys, right here. So I need sine. This one is 50, so it's the adjacent side to hypotenuse. Adjacent to hypotenuse, which one's that? Cosine. Okay, so cosine of 30 degrees is adjacent, which is now W, which is now 50, right? I can just write in 50 in here. 50 over T, is that right? Oh, a little bit different now, huh? Because now the 50 is on top. So if I multiply both sides by T, I'm going to give myself T cosine of 30 degrees is equal to 50. And this time I got to divide by cosine 30. Cosine 30. So I know T equals 50 over cosine of 30 degrees. Answer is 58, I heard. Yeah, is that right? 58 pounds. Okay, so now let's get our notation correctly here, real quick here. So T is not that because T would be a vector, right? But forces are magnitudes. So everybody okay with this? I'm going to say the magnitude of H. Go there, and the magnitude of H is 29 pounds. And the magnitude of T is 58 pounds. Are we good there? Ours, let's see, guys. 5-year-olds, they're about 50 pounds ish. I, I thought like it's 10 pounds per year, I think, wasn't it? Something like that. I think that's the rough rule. All right. Let's see. Okay, fun story. So my daughter, she works for an engineering company, and there's an engineering company here in town. Won't say the name. So they were putting up a building from scratch, and they're a tech company, and they do web hosting for like a whole bunch of different companies. And so what they needed to do is they needed to run cables. So it was cables from the main server here, and then you have all these desks that are over here, right? So they had an option early on to either run it along the ground to here, right? And they decided, no, we're going to run it along the ceiling or in the attic and then bring it down. So what they did not think about was how many cables they needed for all the stuff that's needed. So they didn't want to go wirelessly because that was an option. They're like, nope, it's gonna be cable down. So the engineering company had to then build in supports right here because of all the weight that was here, right? And so they had to calculate the tension of all those wires. And so eventually what they do is they build a tube. Eventually they had to do is build a tube all the way across like this to support that. And then the tube itself was supported by all these different things. And it was massive. They were running it, I think it was 20 feet across the building. And then it was just wires and wires and wires. They had all the stuff for it already. And so they figured, look, instead of having wires everywhere along the ground, we're just going to leave it on top anyways. It looks cleaner and stuff. But it's still, they didn't expect all the stuff that needs to happen. So it ended up costing them twice as more than they realized. And then remember adding another workstation here and here, now you have even more cables, right? So each time they add another workstation, because the company grew all of a sudden. And so then, okay, now it's going to cost you that much in order to run the wire just because of the force that's needed to keep that upstairs. And, oh, interestingly enough, though, so then, and then there's has to be requirements for earthquake, right? So then you have to have enough support there so that the beam can hold, and so that does not fall down. So, so now the beam has to be stronger too. So they had to upgrade all the wood structures on the attic in order to support that stuff. And it like, wow, it turned out to be a little more expensive than they initially thought. Anyways, but that's about forces there. Okay, we are done with 2.5. So we figure, let's see, today's Monday, right? I know a lot of you guys will not be here on Friday, so I figure do Monday of next week. And I am thinking probably the best way to do it is let's come back Monday. We'll just do a review on Monday, and then we'll do test Wednesday. All right, and you guys have a wonderful day.
Thank you.
Thank you.